Hi everyone, welcome to Zmotion technical support video. Today let's see how to achieve I/O input and output for Zmotion motion controller. Before software development, please do controller wiring. If there is no controller, simulator can be used. Connect to the program through the simulator to debug firstly. Then connect to controller to run. Here, we take the MC306X as the example, and there shows the connection configuration. For the MC432, it could be SYN-bus drive interface is included. Next, let's learn some basic information on the MC306X. There are two ways to check. One is through hardware manual. Another is through programming software ZDevelop. Now, let's see. The MC306X has 6 basic axes, which means it can control 6 pulse motor axes actually. These 6 axes belong to differential pulse output, and all axes are with a BZ differential encoder feedback input, but it can be extended to 12 axes at most. For input and output, there are 24 inputs and 12 outputs, and each axis terminal has 1 input and 1 output. It also has 2 PWM, 2 latch channels, 2 internal analog inputs and 2 analog outputs. There is 1 power supply, which is 24 voltage direct current. And it can be seen there are many communication interfaces, including serial ports RS232, RS485, RS422 and net port Ethernet, UDISC and CAN. Among serial ports, RS232 is port 0, RS485 is port 1 and RS422 is port 2. Using ZDevelop, it needs to build the connection with controller firstly, then enter $max in the online command bar. Below shows printed hardware parameters for you. Then, similarly, controller state can be viewed through ZDevelop. Click controller, state the controller. You will see this. Generally, there are 3 things. Basic information, ZCAN node and communication information. If the controller is with bus interface, it will show slot node. It is very convenient. Okay, now we have gained some basic introduction on the MC306X. Then see some relevant to the same input and output function. For general digital input port, it can be connected to NPN type. And actually the opticoupler and the filter are to prevent the interference signal from entering the controller. What's more, the input port has special functions. For example, in 0 to in 1 port has the functions of latch input A and latch input B at the same time. In addition, the hardware delay time. The latch high-speed input port allows 1 microsecond, but others allow 50 microseconds. Even though there are special functions, no definition for special signals. They are all general. And these are all set through software instructions. Following show some. Input inverse instruction is to inverse the electric level of input. Input filter instruction is to increase filter time in the strong interference. Input reading instruction it can achieve how to read input data. And it can read one data or read a group of data. Also, it can be read through viewing in ZDevelop. For reading rising edge or falling edge state, there are 2 methods. One is using one command directly. Another is using 2 commands. This is the input window. It shows input number, input state, reverse state and special input. Namely, it also can diagnose input, and we run below 2 programs to gain this state showing. Next, see output information. Similarly, it can connect to NPN type, and the maximum current of one output is 300 mA. The command is OP. Also, there is special function for out 0 to out 1. They support PWM output. But when PWM function is off, they become general output. PWM high-speed output allows 1 M output signal frequency. Relative instructions PWM duty and PWM frag are to set duty cycle and frequency respectively. In ZDevelop view, OP can check output signal. Please see below. The last 2 means open outputs in bulk as bit. F in hexadecimal corresponds to 1111 in binary system. This command means open output 4 to output 7. C in hexadecimal corresponds to 1100 in binary system. This means close output 12 to output 13 and open output 14 to output 15. Sometimes we will encounter there is no enough inputs or outputs. One expansion module can be used, but the MC306X only contains CAN interface. Then only CAN bus expansion can be done. Please note, make sure connect the EGND of the controller to the GND of the ZCAN IO, and connect a 120 ohm resistor between CAN L and CAN H. Except IO inputs and outputs, analog inputs and outputs are important. The MC306X includes 2ADS and 2DAS using internal power. The precision is 12 bits, voltage ranges from 0 to 10, and expansion module can be used when you need. There are two basic relevant instructions, a in and a out. Check analog information, click View a D or DA. Next, let's see some real functions. Firstly, it can output OP, DA and PWM synchronously in motion. Below are some relative instructions. Move OP means output OP in motion. Move OP2 means it will remain one certain time when output OP. Move PWM means output PWM in motion. And move out means output analogs in motion. The right shows the full routine. Here means close op 0 at first. After axis 1 moved 100, then open op 0. Axis 1 keeps moving to hundreds. Again, close op 0 after moved. The second one, HMI data writing and reading, such as in OP, ADC, DAC, etc. Controller input and output signals correspond to register space to save. And input state is saved starting from Modbus bit 10,000. It only can be read, which means it can't operate input port through software. It needs to be triggered by external equipment. Output state is saved starting from Modbus bit 20,000. It can be read and write. Analog input data is saved starting from Modbus REG 14,000. And analog output starts from Modbus REG 13,000. DPAS, MPAS and VP speed correspond to Modbus IEE, 32-bit floating type register. Thirdly, controller supports software comparison output instruction and hardware comparison output instruction. Hardware comparison output means when motor position reached set comparison position, operate one certain output, electric level changes. And hardware has two kinds. One is that only supports pulse axis. Another supports both pulse axis and bus axis. What's more, it is valid in the MC4 series controller or above. For example, the MC432. It contains 4 hardware comparison output channel, and each channel is independent. Please note it only can compare once in each system period. If the channel is independent, one period supports multiple outputs at the same time. If not, only one can be used. And system period is checked through servo period. As mentioned before, Hubble switch to supports pulse axis and bus axis, and it uses the same hardware resources with move OP. Therefore, it is better not to use in the same one channel. Fourthly, precision output function. This is only valid in controllers that support the hardware comparison output function. The enable instruction is access ZSet, then use the move OP command to take effect. Also, the selected output channel should support precise output. The number of channels supported by different controller models is different. For normal output operation, it needs waiting for one controller cycle. But for the precise output operation, it can respond within one pulse sent by the motor, which greatly improves the precision of the process. At the same time, the move OP delay command can be used to advance or delay the response time. Generally, the precise output function can only be executed once in a controller cycle, and it needs to wait until the next cycle to enable it again. However, each precision output of the latest controller, such as the MC420 scan, is independent, and multiple ports can be used at the same time in one cycle. The last, let's see controller basic program. There are 5 modules. The former 2 are main program modules. Remain are subprograms. Then, let's use our ZDevelop to show you program operation. Open edited program in ZDevelop. Connect to controller or simulator. Connected now. Download the program. Open the oscilloscope window. Configure parameters. OK, all are set, run. When the power is on, automatically run task 0. It executes access initialization program at first. Then execute I/O initialization. Corresponding access initialization program is below. This is I/O initialization subprogram. When initialization is completed, enter while loop to scan. When in 0 rising edge input is scanned, start running task 1. When in 1 rising edge input is scanned, stop task 1. This means cancel all instructions and access stops rapidly. In 0 rising edge triggered motion task 1 to run. Execute motion task, and trigger oscilloscope to capture and trigger input and output running state. Now, simulate in 0 input. And it could be seen oscilloscope starts to capture. Adjust scales and offset for viewing clearly. Next, let's try to press in 1 when program is in motion. After pressed in E, all instructions in motion buffer are cancelled and make access stop. Okay, today's knowledge is over. Thank you for your watching. See you next time.